So I have kept everything at beginner level, so I don't expect you to have prior experience in SAML or any of these technologies. Right, so let's take a look at what single sign-on is, right? So let's say if you are maybe a student, or maybe if you work in an organization, like how many different applications that you are using in a day, right? So let's say in this example, you see there, let's say this is a student who uses email, who now joins online Zoom tutorial sessions, who uses Moodle for learning management system, and then who uses some calendar or timetable application in the university, right? So when you are using these applications, you need to log in with the same, let's say your university's email address and the password, right? So if you have to provide your credentials every time you're logging into these applications, imagine how difficult that would be, right? Same case apply for any employee as well, right? So to solve this problem, what we can do is simply integrate all these applications together with some single identity provider. For example, let's say Office 365. So let's say you go to the email application, you are redirected to the Office 365 from Microsoft, and there you log in with your username and password, and then you start using your email, right? So when you go to Zoom, you are again redirected to the same identity provider where you already are logged in. So you don't need to re-authenticate or provide your credentials again. You can simply log in automatically, right? So this provide seamless integration, like seamless authentication, like you don't need to provide your credentials each and every time you're using any of these applications, right? So that's we call as single sign-on, right? Now let's say where SAML comes into this picture. SAML stands for Security Assertion Markup Language. So SAML is one technology where we can implement this single sign-on behavior, right? So basically these applications like your email, Zoom, these kind of applications we call as service providers or relying party applications. Basically they are sending an authentication request, which we call as a SAML authentication request. This is basically some XML message. It will be sent from your client application to the identity provider. When the identity provider receives this message, it can process it and identify how to authenticate the user, and then send the response. So this again is an XML response, which we call as a SAML authentication response. And then these client applications, so these relying party applications, are able to process this response and identify who the logged in user is, and identify which kind of authorization or the roles this particular user is having, right? And then treat you as a logged in user. That is the basic process. Now, if you have been using OpenID Connect or OAuth, that's again like another technology for implementing single sign-on behavior, right? But today we talked about SAML flows, right? So I will basically start with the demo, so you get a better understanding about the request and the response, right? So for this demonstration, I am using a software called WSO2 Identity Server. It's a free product. You also can download. The basic requirement is for you to install Java, and then first thing is to register a client application, right? Basically, you have a client application, and then which is sending a SAML request to this identity provider, and then you get authenticated, and then this server sends you your client application a response, right? For that, I have already registered my application here. So first, I'll log in and show you the basic configuration. I have registered my application. This is the same process if you have been developing applications using OAuth. Let's say for Facebook, you go to Facebook developer portal, register your application there, right? You put your callback URL of your client application. Same process here. You first, as a developer, register your client application. So I'll show you some of the basic configuration here. I assume some of you might be having OAuth experience. So if you think of the client application's callback URL where the identity provider is sending responses to, in here we call it as assertion consumer URL, right? So some configuration is here, like you don't need to worry about any of these things. I'm just showing you, like to show you like what the setup is, right? And then I will open my client application. This is hosted in Apache Tomcat server, a basic Java based JSP application, right? So I have this login button here. I'll click on this and then it will redirect me to the identity provider. So I'm using Firefox browser. There is this extension called SAML Tracer, or you can use some plugin like SSO Tracer as well. So I'll run it. So you see these messages getting transferred from the client to the server, and then from the server to the client. So I click on this link. Now I get automatically redirected to this identity provider, right? Let's say I use my credentials there. And then before that, I will show my trace. You can see this is the request that my client application sent. So basically, this is an XML message. You don't need to worry if it is like too small. This is XML based request message sent from my client application to the server side. Basically, it has something called this issuer, some name. This will be read by the identity provider, and then it knows, okay, the particular configuration required to satisfy catering this requirement is located at this particular location, and then it will it knows how to process this and send the response to. So basically, these are sample requests. Now I will log in from my user account, right? So I have a sample user account. I use that credential there, sign in. Now you can see I'm automatically redirected back to my client application, and you can see I'm logged in using this email address, and sample attributes of my profile are also sent with this along with this process, right? This is little bit different when you're comparing with OAuth, because in OAuth, what the client application first gets is a token, which then you send to the server side or authorization server or to the resource server, and then you get the users attributes. But here users attributes are contained in the response sent by the server, right? There are different variations as well. I'm not going to details, like there is some profile called assertion queries profile, where you can store the SAML assertion, like the message, and then send it again to request more information. But I'll keep this very minimal so anybody can understand this process. Right, now let's take a look at the response sent by the server. You can see here in my browser plugin, the SAML response sent by the server to the client is displayed. So I'll basically show you. So I'll use some XML formatter and show you. Right, so basically this is the SAML response sent by the identity provider to the client side. It's an XML message, right? And then outer element is the topmost element is called SAML response or response, and then inside the response it has something called an assertion. Now assertion contains the user's logged in user's username or the subject, maybe the email address, and then other attributes. Right, so I'll go into the details a bit later, like how these elements are prepared and which elements we need to pay attention to. Basically, this is the format of the SAML response. It contains the assertion. Inside the assertion, it contains the subject. Here you can see my username or the email address is present there, right? So I hope now you got a basic idea about the SAML flow. Basically, the client is sending an XML-based message to the server. Server prompts for authentication. After the authentication, server is sending this response to the client, and then client is processing this message and looking at the subject, it knows who the logged in user is, right? So I'll continue with the presentation, and then we'll see what are the security threats here. Right, now let's say, in this process, I showed you the SAML response, right? The response contained the assertion. Inside the assertion, it has the subject or the username. What if an attacker captures this request or response, modifies the logged in user's username, and send it back? Basically, this is happening through the browser. So you can use any tamper data or like any plugin, like Burp Suite kind of a software to capture it, modify the response, and send back to the client application, right? Now let's see how we can do that, right? So I'll now in this setup, I'm using a software called Burp Suite, right? This is free software, like, and then inside the Burp Suite, I have installed a plugin or an extension called SAML Raider. which helps me to easily modify my SAML messages and then send back to the server, right? Okay, so and then I'm running a proxy here in my browser. So all my traffic is going through the particular proxy, and then that proxy is hosted by the Burp Suite here, application here, right? So I'll again like explain more in more details when we do the signature wrapping attacks, but just watch what I'm doing here, right? So I'll close this browser and then take it again. Close this as well, take the browser again, and then I go to my client application again. I click on this link and I'm redirected to the login page, right? Now let's say I'll use my username, and my username is Joanne. I'm trying to log in as Joanne, and then I go back to my Burp Suite software proxy, and then I turn on this interceptor. So it will hold any messages going through this proxy and allows me to modify the message, right? So let me sign in now, and then you can see the message is now held because the Burp Suite proxy is holding that message. Now you can see it shows, now I have installed this SAML Radar plugin, so it shows the SAML response capture. Basically, if you also can get an idea, like this is the SAML response. Basically what the server does is, identity provider does is, sends a HTTP post message to the callback URL of the client or the assertion consumer URL of the client. And then if you want to know more information, let's say you can copy this SAML response, take your browser, and then go to SAML decode application like this. Here I'm using this online tool called SAML tool from OneLogin. OneLogin is another well-known identity provider. So that message is URL encoded. So I'll go to this URL decode application first, and then put it there and decode it. This is if you are manually trying to do that task, you can first decode that response and then copy the decoded data and go to the base64 decoder, and then put that URL decoded value there and get the SAML response. So you can see here, this is the XML version of that SAML response. But I'm not going to do this manually. I'm using this simple tool called Burp Suite. The plugin is SAML Radar. I have installed it on top of the Burp Suite, right? Now you can see this SAML response sent by the identity provider. Now it's going through my browser now. I have captured it. Now I'm going to, instead of this joanne@meetup.com, I'm going to put admin, right? So I use Joanne's credentials to log in, but I captured the SAML response. Just put this subject or the email address as admin, and then I'm going to forward it. And then I turn off my interceptor. Now you can see I'm logged into this client application as admin, right? So it's a really simple attack to do. You basically capture these response, modify the attributes you want to modify, and then send it back to the client application. Now you're logged in as that particular user. But in real world, it's not that simple, because I'll explain why, right? Okay, so I'll continue with the slides. Okay, because there are digital signatures, right? Basically, the attack is not that simple, because we are using digital signatures to prevent messages getting modified. If the message is getting modified, the server can reject it. The application can reject it if it knows somebody modified it, right? So I'll walk you through this digital signatures or generation of the digital signature process. Basically, you have the take a look at this left hand side. This is the signing process. This is what the identity provider is doing. It gets that XML message, the response, and then it calculates the hash value, maybe using SHA-256 hashing. It generates the hash value, and then this identity provider is having a key pair, right? A private key and a public key. And then the identity provider is using its private key and then encrypting this hash value, right? And then it's combining this encrypted hash and also it injects something called a certificate. Digital certificate contains the public key for verifying the signature. I'll explain that later. So along with your plain text data, now the encrypted hash is also embedded, and that will be your SAML message or the XML full message, which will be sent to the client. right? When the client receives this message, client has to verify the content is modified or not. So what it can do is simply get that signature value, and then basically get the public key. Public key of the identity provider can be extracted from the certificate attached to the response. So get the public key, decrypt the signature, and then obtain the hash value, the original hash value that the identity provider sent. And then now the content, plain text content or the XML message is also there in this message. So what the client can do is calculate the same hash value on its own, and then compare the two hashes, the one calculated and the one came in the signature in encrypted form. If they match, that means the message is not modified, right? So this is basically the process that we are following here. Now you can see client is sending the request to authenticate, service generating the SAML response along with the user's logged in user's username and the attributes, and then it is generating the signature and then sending this message. Now there are two parts here that you saw already. The SAML responses are there. Inside the SAML response, the assertion is also there, right? So the server is capable of generating two different signatures, right? One signature for the assertion element, like the assertion part of the message, it can generate the signature called assertion signature. And the whole message is called the response. For the entire response also, it can generate another signature, which we call as the SAML response signature, right? So it is up to the, it's up to the administrator to decide, like to proper configuration, whether it should do both in as a response signature generation and assertion signature generation, or only the assertion signing, or only the response signing. It's up to you to configure. So if you, if I show you my server configuration here, I'll just show you quickly. It's for the administrator. Now you can see here, there is this option, enable response signing. So when you enable this, what happens is, this identity provider will generate the signature for the response and then put it in the message. And also in this server, there's no configuration for enabling assertion signing. By default, it is enabled. So by default, the SAML's assertion signature will be included in the message, right? Okay, so I will go back and show you what we are going to do here, right? Okay, now I'll show you how we can prevent this attack happening, right? So in my previous demo, what I simply did was, in the client side, I had turned off the signature verification. Basically, the identity provider is sending the SAML messages or responses along with the assertion signature as well as response signature, but client is not validating because I had turned it off. Now let me turn it on and show you that it actually prevents the attack, right? So I have a small configuration here to do that. This is coming from Tomcat. The particular application I have hosted on Tomcat. I just enable assertion signature verification, and now I need to restart my Tomcat. Actually, it will take a moment. Right. Okay, now my Tomcat is up and running. Okay, let me show you the same attack again. Now the attack will be prevented because the client is verifying the signature, right? So I take my application again, click on this login button, and then I use the same credentials, and then I will capture the turn off on my interceptor from Burp Suite, and then send this message. Now the message response is captured from the Burp Suite proxy, and then let's modify this again, right? Instead of Joanne, I'm putting admin, and then I will forward it, and then turn off my interceptor. And then you can see the client is showing an error, signature validation failed for SAML assertion, right? Because now the client is validating the SAML assertion signature. And then what happened here is I modified the message like username, but the message already contains the signature sent by the identity provider. Now the hash will be different because when the client calculates the hash value of this modified SAML assertion, the hash value it obtains would be different to the hash value included in the signature. And then the attacker cannot generate the signature on its own because he does not have the private key to encrypt the hash value again, right? Because the private key is not shared, it's there with the identity provider. So basically, by enabling the SAML response or assertion signing, and also by enabling the verification in the client side, we will be able to prevent SAML response tampering and then any attack associated with that, right? But we are not done yet. What we are talking today is how to use signature wrapping attacks to successfully bypass this verification, right? Okay, right. Now, if you take a look at the structure of the signature part of the SAML message, or this is common for any XML message, you try to sign it, generate the signature for your any XML content. This will be the signature generated. So basically, it will have some ID and then some information. I'll explain some of in the signature value element, you have the actual encrypted hash value. And then I'll explain some of these reference URI signature methods, canonicalization methods later. But basically, when the response comes, it will include some parts like this, which includes the SAML response or the assertion signature, right? Okay, now we take a look at what these signature wrapping attacks are on XML. Basically, this is common for any XML-based protocol, but now we are using it on top of SAML because SAML is based on XML. Right. So here what we actually, now you are familiar with the SAML response message. It has the root element response, and then inside that it has assertion, right? So you can see in this diagram, what I have simply done is, I have what you're seeing in the green color root is the original message, right? Original root element. But I have taken a copy of that and then modified the entire XML structure of this message, right? So you can see here, I have generated a copy of the assertion as well, a copy of the response element as well, and then prepared my XML element structure here. So there are 8 different attacks like this which are possible. So I'll demonstrate you some attacks, then it will be really easy for you to understand what's happening. So basically, I'll show you the 8 different attacks possible. This attack is possible to bypass the response SAML response signature verification. So if you have enabled the client side SAML response validation, signature validation, by crafting this kind of a malicious payload, you will be able to bypass the verification, right? So there is another type of attack possible, again for bypassing the response signature validation. Here the structure is a little bit different compared to the previous case. You can see in previous case, the root copy of the original root or the response was in a child element of the signature, right? But now it's coming directly under the main root copy of the main root element, right? So you don't need to worry or remember any of these things. I'll explain you how these flows are working when I actually demonstrate these attacks, right? First 2 attacks are on bypassing the response signature validation. Now there are 6 more attacks on bypassing assertion signature verification in the client side. So basically, you can see in the red color, you can see the cloned XML elements. Basically, I have taken a copy of the assertion element and then plugged it as another child element under the main root or main response SAML response message element, right? So likewise, there are other ways to do the same attack. So I'll walk you through some of these things. And so altogether, there are well-known 8 types of attacks: 2 for bypassing the response signature verification, 6 for bypassing the assertion signature verification, right? So, so I have created a setup to demonstrate all these things. You can see I'm running Apache Tomcat server on my port 8080. Inside that, I have hosted the sample client, travelocity.com client application. It's a JSP based application. And then as my identity provider, I'm using the WSO2 Identity Server running on 9443 port. You can use any identity provider for testing this flow, any SAML based identity provider. And then I am running Burp Suite, and on top of Burp Suite, SAML Reader plugin is installed. Burp Suite is running a proxy on listening on port 9090, which is the proxy here. And then I'm using Firefox web browser it is it's using the proxy 9090 port. So my SAML, the burp suite can capture all the request responses, modify and send back. So this is my setup, and then I'll show you the demo. Right. So I'm going to use SAML. This fifth attack here from out of those 8 types of attacks. I'm going to show you how we can do this fifth attack to successfully bypass the signature verification. In my previous demo, you saw we enabled the signature verification, assertion signature verification in the client side. So any modification we do in the assertion, the application will reject after detecting it. But now we are going to bypass it. So here you can see, so I have basically copied the assertion, original assertion, and then plugged it under the root element, right, the SAML response element. And what you can see here is, in the assertion, you can see the ID is put as evil in the red color one. Under that, you can see the red color subject. So that is where I inject the victim's email address or victim's username, let's say admin, right? And then in the original assertion, you're seeing in green color, that will have the original, let's say attacker's original email or the details sent by the identity provider. Now here what happens is, we are simply tricking the XML parser. Now basically when this XML message is received by the client, it needs to process this, parse this, and then perform the signature verification. Now what happens is, it will look at the fake assertion, right? Fake assertion, the red color one. It will go into the signature element of it, and then it has this reference URI. It will pick the reference and then go to the original assertion which has this reference, and then take the plain text data from that assertion, right? So now the red color assertion signature is the original signature. So original signature will match with the original assertion, the green color one. So in that case, we have not done any, we are simply tricking the XML parser to validate the original plain text assertion along with the original signature. But after that step is successful, what the parser does is simply read the username or the subject from the very first assertion present in the tree. So in the XML tree, the very first assertion is the fake one. Inside that, it has the fake subject or the victim subject. The XML parser will read the username from that. So that's what simply happens. Signature verification is happening using the original signature and the original content, but the username or the subject will be read from the fake assertion. So that's simply the process. So I will do this and show you, then it's really easy for you to understand, right? Okay, so I take my client application again and click on the login button. Now I end up in the identity provider's login page. So I'll use my same credentials. Joanne is my username. Let's say this is hacker's credential, right? And then hacker is trying to do this attack, can log in as admin. But now in the client application, assertion signature verification is on. So if the attacker simply modifies the username, then he cannot log in, which you saw before. Now let's see what actually happens. So I take my interceptor again, turn it on, and then click this button. And then now the message is captured. You can see this is a SAML message. So here, using the SAML Radar extension, you can see there's this drop down for different kind of attacks. So you just need to, so I'll make a copy of the original XML content and then show it to you here. Right, so this is my original XML tree, right? Right, this is the original XML. Now I'm going to generate this attack. So here you just need to select the particular attack type from the drop down and click on this apply XSW, apply the attack. So basically this plugin is an open source version of it. You need to generate it and then locate the fake assertion and modify the username. But I took this application and then added an extra text box here. Simply now with this modification, it's really easy. You just need to put the victim's username here and click this button. So it will be automatically generated for you. So you can see here, this is the original assertion where Joanne's details are. and then this is the fake assertion where admin's username is, right? So I'll copy this as well, and then put it here so you can see the difference, right? So I'll do the attack first and then show you. So I basically applied this attack, and then if you are interested, you can download this modified version from my GitHub repository. I have found this SAML plugin and modified it, and you can find this jar file which is installable, can be installed on top of burp suite. The addition is this extra text box here. It's really easy for you to put the victim's email or username and click on the button, right? So you can download this modified version also from my GitHub. Okay, now I modified it. Now I'm going to forward this request and turn response and turn off my interceptor. Now you can see I'm logged in as admin, right? So basically the client is actually doing the signature verification on the session, but still we bypassed it, right? You can see some other attributes, but I did not touch them. You could have modified them as well, right? So basically I demonstrated using this burp suite plugin, SAML plugin, you transform this to that malicious payload and then send and trick the parser to pick up the modified username, right? So I'll show you the XML structure here. This is the original response. It had the original assertion and all, but this is the modified one now, right? So this is the modified one. You can see two assertions here. The response is there, two assertions, and then first assertion is having this subject as admin, so that is a victim, right? And then the other one is the original assertion here. It has the Joanne or the attacker's username there, right? So important thing to note here is the reference. Actually, you can see here in this fake assertion, right? In the fake assertion, you can see ID is put as evil assertion ID, and then if you expand it, you can see this reference, right? I'll show you the reference here. Okay, so inside the signature, you can see the reference here. So this is the fake assertion. Inside that, it has the original signature. Original signature reference is this one, and then the same reference number is there in the original assertion as well. So you can see the fake assertions has this reference inside the signature. It's pointing to the original reference in the original assertion, which is this one, the ID, right? So basically, so that's how we trick the parser. So it will look at this assertion, and then this is the ID, and then the corresponding signature for that is in the signature element under the fake assertion, but still they match because we have not touched the signature, right? But when it is processing, after that step, the XML parser will pick up the very first assertion, which is the fake one, and then the subject will be read by that one, which contains the victim's username. So that's how it works, right? So I will continue with this. I hope you got some basic idea about this attack. Even in this diagram, you can see here. So the reference in the signature under the fake assertion points to the original assertion. So the signature verification will be successful, right? Okay. Now this was published long time back. These 8 types of attacks. So these are some well-known SAML-based identity providers. They have already fixed these vulnerabilities, and then they have released security advisories and all. But the problem is this. Now the problem is not with the identity provider. The problem is with the client application, right? Because client is the one who's processing this message. Now imagine, let's say Office 365 might have fixed it, or one login, ping identity, in any of them, they have fixed it. Where they have fixed it is when they act as a client. So in a scenario like this, where your client application depends on Office 365 authentication, and then Office 365 redirects you to Salesforce login. So your user account is actually residing in the Salesforce account side. And then what happens is, let's say in this case, Office 365 is also acting as a SAML client. So if the Salesforce's response is modified by the attacker, and then since Office 365 is already fixed it, they are not vulnerable. but if somebody attacks the response coming out of the Office 365 to your client application, still the vulnerability can be there. So the actual fix should be done in your client side. Basically, otherwise using a well-known identity provider would not be helpful in this case, right? So these are some preventive mechanism steps. If the SAML client is implemented using a third-party library, then you need to make sure that library is secure. Basically, let's say if you are writing a Java-based application, like the one I showed you, you can use OpenSAML kind of a library to do all the signature verification. In that case, you need to use the OpenSAML particular version, which has a fix for these signature wrapping attacks, right? Or else if you're implementing your own way to do that, you need to make sure you are correctly doing these validations, right? And then some of these examples would be like checking multiple responses are there, or checking multiple assertions are there. If so, reject the message, because maybe in your case you only expect one assertion to be present, one assertion element to be present in the entire XML body, right? And then conduct penetration testing, like the one I showed you. I'm using a sample like some penetration testing tool like Burp Suite and then SAML Radar. You can do that, and also you can make your own tools as well, because here I'm taking the SAML Radar plugin and then added some text box for me to help like do the attack quickly, rather than going through the XML body and trying to find the particular fake element and modify it, so which takes time, right? Okay. So I hope you got an idea about XML signature wrapping attacks, but we are not done yet. The XML signature wrapping attacks, well, they are since like from like 2010 maybe, right? And then, but so this is a new type of vulnerability which was discovered in 2018, right? So I'll show you what this attack is. Now, if you take an XML message, there can be elements, and then in the values, there can be XML comments, right? So here in the line 1, you can see there's an element called A. It has some attributes, X and Y attributes, forget about those. And in the inside the body of this element, right, where actual value is there, you can see some text is there, and then an XML comment is also there, right? And then on line 2, you can see another message which does not have the XML comment, right? So basically, both the messages are same logically, right? But if you just take the text, those are different, because text-wise, those are two different strings. But logically, they are equal, because the XML comment should be ignored, right? Okay. Now, how does it impact the signature verification, right? Basically, so if you take these two inputs for signature generation, we need to do something called canonicalization or XML transformation. So basically, we take the input, convert into some other form before we actually generate the signature. So that's what's happening. So let's see what this canonicalization is. For canonicalization, we use different algorithms. You can see there's one algorithm called EXEC14N hash with comments, right? So if this particular canonicalization algorithm is used, you need to consider comments also as a text value for generating the signature, right? So you can see on my first line, which has a comment. So if you are using this particular with comments canonicalization, you transform it such that you take the string value of the entire element along with the comment, and then you generate the signature, right? And then for the other text, like other XML message which does not have the comment, because the string value is different, now it will end up having a different signature. Basically, although these two messages are logically equivalent, if you are using this particular algorithm for canonicalization, those will end up with two different signatures, right? Okay, now there's another well-known canonicalization method to ignore the comments, EXEC14N, that's commonly used. So if you are using this particular canonicalization method algorithm, what happens is basically it will skip the omit the comments in the XML message. So basically, when you input these two inputs to this transformation process, it will remove the comment and then take the text and then generate the signature. If this is the case, you can see both text will end up having the same signature, right? So now what is the danger here? Let's take a look here. So there is an issue in this approach actually, because the issue is actually with the XML parsing. So when you have an XML element like this, node A is there, it has some text, it has a comment in between, then it has another text, right? So basically, you are using an XML parser like DOM parser, SAX parser, or something like that. You might be calling a function like node particular node dot get text. So the problem is in the implementation of this get text or get string or whatever that method in these DOM parser or SAX parser or whatever the library. So the problem is sometimes it actually tokenize this content of the element and then return the first part of it that appears before the commit. Sometimes some of the parsers are behaving such that they return the second part of it, right? So in this example, you can see when you are trying to extract the text of the element username, this actually returns the first part, which is fill. So my username is Philip, but so inside that you have this comment here. So basically it will this particular, if this is how the my XML parser behaves, it will return Phil instead of Phillips, right? And then there's another way. Some parsers are actually returning the last token of it. Let's say Joanne is my username, but after JO I have put my comment. So when you are trying to code and then extract the entire value, it's actually returning the last token which appears after the commit. So now that's where the danger comes in. So I'll explain an attack with that, so you will see how we can exploit. So basically what you need to remember here is if you are using this EXE-C14 kind of an algorithm for canonicalization, it skips the commit. Basically, no matter what you are putting in the commit, signature will never change, because for signature generation it is skipping the commit and then only extracting the other part of it, right? But when the parser will go through the signature validation process, after that it will extract the text appearing before the comment or after the comment. That's where the danger is. So I'll show you a real world attack now. So I close my browser again, take the browser, I go to the application, I click on this link, I end up in my login page, I use the Joanne's credentials, 1, 2, 3, and then I turn on my Burp Suite interceptor, click on this button, and then capture the SAML response message. And then I'm not going to apply any of the signature wrapping attacks here, right? I'm simply modifying this username here, subject. After JO, I'm going to put an XML comment, right? I'm going to add this XML comment, and then JO, then the comment, then and at meetup.com. That's what I simply did. And then I'll show you the canonicalization method a little bit later. Here you can see that without comments canonicalization method is used. So I simply forward this thing, turn off the interceptor. You can see I have logged in as and at meetup.com, right? So basically here how the parser behaved was simply it took the last part of the text right after the commit. But some parsers behave differently. They might be picking up the first part of the string. In that case, what you need to do is the danger here is actually if any system allows you to self sign up, like you can create your own account. You can let's say you want to attack admin's account, you can create an account like ABC admin, right? So admin is already there for administrator. You create a new account called ABC admin. Then after ABC, you log in as ABC admin, and then after ABC, you put your comment. So then you will be logged in as ABC, admin. So that's the danger in it. So so this was reported like in 2018, and all these major identity providers, they fixed it. And then the danger is again they are in your applications, because your applications are the ones who are processing it. So you need to make sure you are preventing this vulnerability also in your applications. So how to prevent this? Maybe you change the canonicalization algorithm to verify with the comments. So that change should be done in the identity provider side. If the identity provider is supporting that, you can configure that. And then if the without comments algorithm is used, you need to make sure when you are reading the username, don't use some libraries method, just text processing, get the entire text, remove the comments, and then whatever the tokens remaining, append them, concatenate, then use it as the actual username or actual value. And then use some well-known libraries which are not vulnerable to this attack. So if you are using, let's say, DOM parser or SAX parser kind of a library, make sure you use the latest version, and also make sure these versions are not having this known vulnerability, right? If they are vulnerable, then maybe you need to have your own logic to text process that and then remove the comments, right? So I'll show you the this canonicalization method. Here, if you see the signature, let's say, so in this original one, under the signature, you can see this transform here. So here under the signature signed info element, you can see this transform. So basically this is EXC14N, which means that is the one without comment, right? So the XML parser will take a look at this transform element, whatever the algorithm there is, and then doing the signature verification according to that transformation, right? If it is with comments algorithm, then it will take the entire string. If not, it will remove the comments for signature, where the danger is because attack is able to put some comments and still maintain the same signature value, but try to attack your parser, trick the parser to pick the token from the first part or the last part of the element. So that is another vulnerability that you need to check on when you're doing SAML based penetration testing, right? So I covered the XML signature wrapping attacks, and also this is a new vulnerability, XML comments identified, discovered in 2018. So basically I introduced you what single sign-on, and then where we use SAML, and then what are the digital signatures, and then what are the XML signature wrapping attacks, and then how do you do the penetration testing for SAML flows, and then using XML comments, how to bypass the signature verification and then trick the parser so that you can do some privilege escalation attack. And then finally, how you prevent it. You need to make sure your client application is securely parsing, and then use well-known libraries, and also make sure these newest versions are not vulnerable to these attacks. So I covered what I had already planned. So if you have any questions, I'm happy to answer them now. And then like when these major like identity providers are vulnerable, like they release these kind of security advisories. So what you are seeing on screen now is the advisory release from WSO2, because for this demonstration I used very old version, but again I did not attack the identity provider, I attacked the client application. But in a scenario where you do authentication chaining, like I'll show you on my screen like this. So here maybe we could have used the identity server, WSO2 Identity Server, any product in the middle. And then if it was vulnerable, now it is not, because they have already released the patches. So there's no problem using this product for demonstration. So, but if you install the patches on top of it, then again, like when this product acts as the client, the attack won't be possible, right? And then if you're interested more, there is this research paper on breaking SAML. So it has more information of how these attacks are done. This was published in Usenix conference in 2012. It's a very good like A-star conference. So it has all the details how this technically how this attack is working. So if you're interested, take a look at that as well. And then the last attack I showed you with the XML comments, it was discovered by this Duo security team. So there's this very good article about how they found this vulnerability, and then how this XML canonicalization is working, and then how to exploit it, how to fix. So all this information is out there.
That's fantastic. Thanks, Terry. Oh. Yeah, I'm just switch back to this view here. That was really interesting. There was so much information there. I don't know how you managed to pack that all into 45 minutes. I'm probably gonna have to go and listen to that video again just to get all the details of it. It was really interesting. I'd love to. I've done a little bit of hacking on like the PHP based applications, and but I've never really done any in-transit hacking of credential information. When it comes to JSON, JWT is possibly a little bit, but SAML for me is a fairly unknown topic. So I'm definitely going to go through your code and your samples up on the GitHub repository and see if I can replicate some of that just for fun, really. But for now, that's all for this stream. Thanks again, Tharindu, for joining us, and we look forward to chatting you into the Zoom channel shortly. Thanks a lot.
Thanks.